This is the Mechanics Homework Booklet question 12. We're told the figure below shows an apparatus used to locate the centre of gravity of a non-uniform metal rod. So here's a non-uniform metal rod, and it's being lifted at one end by Q, it's being held up at the other end by Y, P, and we know that at some distance D along its weight is acting. We don't know what that distance is because we're trying to find the centre of gravity. The rod is supported horizontally, so it is held horizontal by two wires which are both in fact pulling vertically, P and Q, and is in equilibrium. First of all, Ross, state the two conditions for equilibrium. That's simply that the resultant force is zero and the resultant torque, the moment of the resultant couple must also be zero. We're told wire Q is attached to a Newton meter, so the force on the wire exerts on the rod can be measured, and the reading on the Newton meter is 2 newtons. The weight of the rod is 5, so we've got to calculate the force that the wire P exerts on the rod. So if we just come back here, I've got a total downward force, the weight of the rod is 5. We're told that we've got an upward force of, 2 newtons there. And of course, very simply, the total weight downwards must be the total forces upwards. So the 5 is equal to the 2 plus there. So that one must be 5, take away 2, 3 newtons, which is what I've got there. We then also asked to find the distance D. So what we need to do is to take moments about the left-hand end. Why do I choose to take moments about the left-hand end? Well, I've got a force there that I'm not particularly interested in, and I've had to calculate, so I'd rather not include any calculations I'm doing of moments. So if I can make it 0 from the point I'm taking moments about, a distance of 0, then its moment will be 0, and in essence I can ignore it. So what have I got? I've got clockwise moments of the 5 newtons to weight multiplied by the distance D, and I've got anti-clockwise newtons of the measured 2 newtons. The measured 2 newtons we have there multiplied by that 90 centimetres. So if we take that down to the working area, I've got the 5 newtons times that unknown distance D is equal to the 2 newtons times 0.9 of a metre. So if I then rearrange that, do the calculation, I end up with D is 0.36 metres. So that was the Mechanics Homework Booklet question 12.